with a set of notes. Let's wait for that to come up. All right, so you should be seeing it. This is an overview of the minor in social data science. So good. You can see that moving on to the program. So I wanted to start with just like a one-page summary of what's actually going on here. And here it is. What's the goal? It's to better prepare students majoring in the social sciences for the data-filled world they graduate into. So just being, that's a very clear statement of what the motivation of the minor is. But an important thing is it's meant for students who are in departments in the division of social sciences. So it's not for, say, students in the division of life sciences or the physical sciences. And that's not because we don't like those students. We like those students just as much, but we wanted to have one that really met the needs and the goals for the social science students. So that's what the selection is. So that's quite an important component to it. Now, as you know, the social sciences are very broad. But one of the things they have in common is the word social, which basically means relationship. So what it does is it has a lot of data in the social sciences, which deals with the relationship between typically people, but the relationship between things. So that in and of itself makes the data that's used in the social science different than data, say, in other areas of statistics, which as you probably know, relate to the individual. We have populations of individuals, and we look at characteristics of those. Where, in a nutshell, you could say the social sciences much more focus upon the relationship between individuals. Other sciences focus upon the individuals directly. So that is one of the core differences. I'll expand on that as we go through. But if you start out, why are the social sciences different? That is the reason why. So the idea is after a core class in the social science department, which a statistics class or a methods class, we then take a core sequence of 4 classes within the statistics department. And then there's electives, a couple of elective classes, which are typically chosen from the focus area of the student. And that can be in their own department, or it could be in any other department also, but it just gives them an idea to have a focus or to tailor the minor to each of the individual student needs. Now, the idea of that, it's also note that, as many of you know, but just to be clear, we're all on the same page, there's an existing minor in statistics, which has been very successful. It has typically about 151 students in it now, and that's sort of where it is, maybe increasing a bit, but of that general number. And that's serves students across the college, across the university. And that's proven to be a very good set of classes. The social data science minor is a variation of that. It's certainly different, but it's of a similar style. So as a result, we think that the minor is going to do fine just because we've got some experience with a similar type minor to it. Now, the other thing is that most of the classes in it, almost all but for perhaps one, are regularly taught in statistics at this moment. So we obviously, as a department, teach a large array of classes. So we've, in essence, chosen the ones that are most appropriate for social data science from that set. And also, we've gone out and identified each class offered by our department within the social sciences, or at least classes which are most useful for social science students. And then we've created a list of those so students can know which classes they can choose to be their elective classes for their track. Now, they can also choose statistics elective classes, but we wanted to have a much wider range of classes for the students to take. And so we've created that list for them. And the last thing in the overview I'll note is that it's this social science or social data science minor is the first in the world that we can find. Now, there could be one at the University of Antarctica, which we haven't found, or something like that. But if you're going to take this minor, you'll be one of the first students in the world to take something like it. So that's always nice to be involved in. Now, I'll just pause here to see if there are any questions. I'm going to go into details in many aspects of this, but this is sort of the core outline of it. Let me just pause for a minute. You can either throw it into the chat or just take yourself off mute and start speaking. All right, that's fine. I will now continue on. All right, so background and motivation. Now, I'm assuming that a lot of people here are people who are not actually in the Stats Club in a direct way, so they want a little bit of sense of what this is about. So I've got some background on what the statistical sciences are and what data science is, just to be sure. Now, implicit in this, the idea of this minor is it's a minor in data science, really trying to be available for students who typically wouldn't choose data science. So in other words, if they were already going to choose data science, they might do the minor in statistics. So this is supposed to be one that has a broader reach than the minor in statistics within the social sciences. So what are we doing? Well, just to remind ourselves, the core idea in statistics is really addressing the question, how do we learn from data? Data itself is central to the actual field. Everything we do is data centric. And it's really important to note this because it's in essence what every question in the field is relating to. So in that sense, statistics is solely a data science. All of statistics is data science, but it's also true to say that not all of data science is statistics. There's areas of data science which are not statistics, but certainly all of statistics is data science. But what is statistics about? It's about how to design studies and how to analyze data. So typically it has two components to it. Firstly, it talks about how to actually collect data. In other words, what is the best data to collect? What is the most efficient way to collect it with the final goal of learning from it? So it's like if you design your data collection activities accurately, you can do a lot more learning than if you do it in an ad hoc or inefficient fashion. So how to design studies or ways of collecting data is a big part of the field. And the other one is how to analyze data. Given you've collected data from a study, what's the best way to learn from it? What's the most efficient way? What is the way you can get to the answers more quickly? Or how can you make best use of the data you have? Or how can you remove artifacts in the data that make it really difficult to see what the data is telling us about the real world? From a statistician's perspective, what we really want to do is this first bit. We want to learn. And the data is telling us about the world. It's speaking to us, but sometimes it speaks in a language we don't quite understand. So our purpose is to understand what the data is saying so we can understand what the world is about. In a nutshell, that's what all statisticians do. All right, now the other thing that's important here is that role has changed very dramatically. You know, when I first started as a statistician a long time ago, what we did is really different than what we do now and what you'll be able to do after you leave UCLA. So it's a great time. It's also, there's an enormous demand for statistical thinking in the world. So just being a statistician is a great thing, but this minor, which we're focusing on, is a step right in that direction. Now, let me be a little explicit why things are changing. Well, in a word, it's computer revolution, which has been going on for a long time, since the 1960s. You know, but it's really changing the world. And it's changing the world both in terms of what tools we can build from that, what technological tools, but a really important thing that's coming into the background is automatic measuring. So, you know, when I was coming through, we wrote numbers down on a piece of paper and did work on them on a piece of paper. And now, in previous decades, they came electronically. They were stored on a computer. But now what they do is you automatically come on a computer. You don't necessarily collect them yourself. You have the computer itself collect things. And so that leads to enormous size of data and different subtlety of data and detail in data. So this is really just transforming, obviously, the sciences, but commerce, and we can have many examples, but most importantly, society itself is being changed by all of these things. These are not subtle processes, and we could probably spend hours talking about each of these things, but I'll just note that now. All right, so having said that, what is data science? So it's mostly a superset of statistical methodology, which I've just been speaking about, mathematical foundational ideas, math to understand. Math is a very concise, powerful language of expression. So what we want to do is express ideas, very powerful ideas, very accurately. So the more math we have, the better we're able to express those things. It's as simple as that. It's a language of expression. Statistical approaches to data analysis, so-called exploratory data analysis, how to analyze data. So that's a really important thing to have. If we're going to have a data science, we've in essence got to have a lab in which to analyze data and work it over, so to speak. So that's what this is about. Now, it's also something called machine learning, which you put in quotes. Now, what I would say this, with my statistical hat on, what is machine learning? I would say it's modern statistics not done by statisticians. And I don't mean that negatively. It's a fantastic amount of work that comes under the heading machine learning, which formally means methods and technologies by which artificial people or artificial components, machines, learn about the world. Well, we've just said statistics is how to learn from data. So this is basically, this is how artificial or AIs would learn about data, but that's very closely allied. So I view machine learning as in essence, doing the same thing as statistics is doing, but by people who are not necessarily call themselves statisticians. So it falls within that group. I can say a lot more about this, but I'll leave it for questions. And the last thing I think it's worthwhile to actually note is that it's a lot of technologies about scaling up to have, and in quotes, big data. Now, I'm sure you've all heard this term and various components, but all it really means in the context of the world is that because of computers, we're able to collect more detailed, more frequent data on individuals and things. So in other words, it's the detail, the scale, and the types of data, all of which have rapidly improved. And that doesn't fundamentally change things. It's still the same principles apply, but the impact of that upon all of these components is very profound, just because of scale. All right, so just quickly, for those who are statistics majors here, the statistics major here in the department, because of the history of the department, is in essence a data science major. So the university does already have a data science major. It's just called statistics for historical reasons. And here's the key connection. The current minor in statistics is in essence a minor in data science, but what we do with the social data science minor is it's the minor that focuses on the types of data that social scientists see. So in other words, same thing as the other minor, except it's really trying to focus on the sort of data that social scientists will see while they're doing their classes here, but also when they leave UCLA and go out to the real world. All right, I'll also pause here to see if there's any questions or other comments. Oh, I'm going to get things at the end too, but let's, I see a question from Kathleen. Is it possible to do a double minor in social data science and stats? If not, what would be the reason to choose one or the other? Great question, Kathleen. And the answer is absolutely not. If you're doing the minor in statistics, you cannot do the social science one and vice versa. Noting that to do the social science one, you already need to be majoring in social sciences. And the reason for splitting it would be if you're a social science major who either wants to continue when they finish university in the social sciences or will take a lot of social science classes, you're much better off taking the social data science one. If you think you're going to leave the social sciences, then yes, definitely do the minor in statistics. But that's really where you see your future at. That should determine it. They're about the same amount of work. They're about the same technical level. So the main split is, is on the social data. So in other words, will you be addressing social science questions? Great. Okay. I will go on. All right, so I said a little bit of this when I started, but I wanted to expand on what's different about the social sciences. This is important for the mind, but also actually important for social scientists. And what happened was that, again, when I was coming through a while ago, the social sciences was typified by having very rare data, or data was hard to collect. It was often collected by hand. It took a long time. You had to do things like interview people. You had to do things like go out and ask people questions, travel to them and things like that. And so most of the methods in the social sciences either were not statistical, and by which I literally mean were not data-based. They were based much more on theoretical ideas and other components like that. But it wasn't because they didn't want data. It's just the data they had was not of a quality or a quantity, to be more precise, or both, not of the type and the quantity that enabled them to address social science questions accurately. Now, what's happened is, just like every other field, that's changed. So the social science is now getting an enormous amount of very detailed and very complex data. By complex, I mean, it could be something like a social network data. We have detailed information on who relates to who, and all of those things. You have these strong interrelated observations, or kinship networks, who's in whose family, ancestral networks over time. I could go through and give many, many examples. So the idea with that is that they've got an enormous explosion in the data that's now available. So what they really need are methods to analyze that, and statistical concepts and data science ideas. So more and more of your classes are going to have data in them and be influenced by data, but most importantly, much more than the past. In the past, there was not so much statistics work in the social sciences, and now there's an enormous amount. So we're really looking towards the future here. So just a couple of other notes about, there's a lot of tools coming in, machine learning tools and computational methods. Now, just to be a little clear what we say about computational, we could have a method that relies instead on a mathematical representation of a theory. It will be represented computationally, that is, as an algorithm or a computational device. So the two are closely related to each other, because you could view an abstract computation as in a mathematical way, and in fact, they're often expressed mathematically. But the idea is that you would express it, which it could be written and actually realized using a computational device rather than purely a mathematical representation. So this is in some ways a subtle form, but really I'm putting this here just to note that it doesn't necessarily need to be statistical. It could just be a model itself, and a computational model. And just some examples: geographically indexed information, network data, relational data. It could be marriage data, who is married to who. Observational data with causal aspirations. It's really important to determine cause. There's so many questions in the social sciences that are questions of cause. What causes what, or what caused something, and what led to outcomes. Really important questions. And then there's societal impacts of data, the way our society is changing in response to the data we now have exposure to. All right, so what is data science? The science of how to learn from data. What is social data science? How to learn from social data. So that's what this entire minor is about. All right, there's some questions there, but I'll probably wait to the end to answer them. So some basics of the minor here. Requirements for the minor: there are 3 lower division classes, about 12 to 13 units. The core of it, when you take the actual minor itself, there are 4 core classes everyone must take, which is 14 units. They're on the statistical modeling fundamentals. The focus of these are on the modeling aspects of statistics, because they're the most useful to social scientists. And then we'll also look at the societal impacts of data, which we think is an essential component in this day and age. You take those 4 core classes, then you take 2 electives, and they can be chosen either from statistics or any of the social science departments. And we have a very explicit list, so this is easy to actually find. You can choose any 2 from that list. So 34, 35 units total, with a whole bunch of different focus tracks. And I can describe these more accurately, and I've got detailed notes on them. But just to give their titles now: econometrics, typical for, econ majors; politics and society, very commonly taken by political science; data ethics and society, this is more on the social impacts of data. I could say more about this. Social networks, something that would be very common in sociology; geographic information, geography; and then general, which you don't have to have a structure there. These are just, there's no, you're not sort of forced into one of these boxes. We just wanted to give some guidelines. If you wanted to focus on these, we give suggested classes to actually take. Okay, all are currently offered, so they shouldn't be very hard to actually do it. Okay, so I'll just go through this slide, and then I actually have a lot more slides, but I'll stop for questions, like real questions, and then we'll see where that leads us. So firstly, major in the social sciences is required. Who will teach this minor? In statistics, it's exactly the same mix as we have for our other programs. So it's a mix of ladder faculty and full-time lecturers. The statistics department's well known for having some excellent faculty, and it'll be the same faculty. In the social sciences, it's mostly going to be ladder faculty, because most of the classes listed are advanced classes in those areas. So it's often the ladder faculty who will be teaching those advanced classes. So that's good. And often the social science department, when they teach these classes, they don't have an enormous numbers of students in them. They might have smaller numbers. So it's a good opportunity to get into classes which have smaller numbers of students in it. For advising, the person to go to is, if you're in the social sciences, is not necessarily your SAO in your home department, but Michael or Mike. So Mike's here. And the last two things I'll note is, and I can probably show this, or I think Amy might have just put the link in the chat. There's a catalog description of the minor, which I can describe. There's a link here. And we also have a departmental webpage and worksheet. And a little later, I'll go through those, but I'll pause now and answer the whole bunch of questions, and we'll just see how far we want to go in the details. So, questions. Let me just, I'm going to roll back and answer these in order.
Mark, I've answered a couple of them. You can
sure,
just,
no, Mike, actually, you can answer as many as you like.
If you could just take the ones that have, have to do with the material and all that kind of thing. So there's one that says, we're taking this minor to help us prepare for the machine learning AI field once we graduate. That one's for you, Mark. Oh, you're muted.
Actually, yeah, could you repeat that? I was just looking
Sure.
at the question.
Yeah. So some of them, that had to do with administration. I was just answering.
Okay.
So this question was, would taking this minor help us prepare for the machine learning and AI field once we graduate?
That's an interesting question. So again, this is presuming you're in the social sciences, right? Coming through the social sciences, have a social science minor. And the short answer is yes, in the sense of, given that you're doing the social science major, it's probably the best introduction you can get to data science. And so it's very good. The way I think about it is, if your primary love is a social science field, let's say it's anthropology, you can do that major, but also then come out with a minor that's going to help you in the job market, help you get into grad school, because it's data science. And so it's very, this is obviously one of the hottest areas around. So you can have it both ways with this minor. So what we don't want is people to do the statistics major and leave the field they sort of want to do because they feel that data science is so hot. So yes, it is important, and it is a good way to do the major you want, but also have data science on your resume. I would say that if you know you want to be a data scientist, if you just know you want to do data science, then you're better off doing this the statistics major and following it all the way through. But I don't want to emphasize that. The intent here, and I think it's, choose the major that you're really interested in, your primary thing, and then just get the data science credential, because that's really telling employers and graduate schools that you can do both. I'll hand back to Mike. Yep.
Yeah, I'm just going to read another question here from Jennifer. Are there any programming classes involved in this minor? If so, which languages?
That's I'll answer that, Mike. So there's Stat 20. Let me actually bring up the page here. I might do that again. Share the screen. Is that coming through the web page for the social data science? You can see this is the catalog link. If you look on the actual catalog here. So if you go through the minor, one of the lower division classes it says is Statistic 20. And this is our introduction to programming with R. So you take your first class in statistics, which gets some fundamentals ideas in, and that's either one of our stat 10 through 15, which are in essence introduction to data science, or you take one in your field. These are just standard methods classes in each of some of the core social science departments. You can take those also, and then you take Stat 20. So Stat 20 is Introduction to Programming with R. So it does two things. It teaches you how to program principles, but R is a very high level language. So it's possible to do very powerful things with it. So you learn to program, you learn programming principles, and you learn programming tools as well. So it's a four credit class. It's also required because without that, there's a lot of programming in the other classes you'll be taking. Many of the social science classes use R because it's a very powerful tool. And so I think it's, you'll be doing that. But just to be clear, there's no pick classes in it, pick 10 or anything like that. That's there are other majors which have those. The minor focuses upon R. Okay. You want to go through the next one, Mike? And
let's see. I've answered some of these, but maybe I can read them out loud anyways. So when does enrollment start? We've already started. So as soon as message center is open. So if you guys send it to me over there, we'll just go ahead and review it together, depending on where you are in your DARs. Let's see. I think we're pretty caught up here. I was just about to answer Michael. Public affairs, I believe, is not under the social science division. It's a different school. So I'm afraid the minor is not open to you if you're a public affairs major. I guess we could still answer something about econometrics. Is there a good program if you want econometrics, Mark?
No, I actually don't think so. There is an econometrics track where you can take two classes, typically from the econ department. But as you might know, econ is, although it's statistics very applied to economics questions. And I think it'd be much better to directly take classes from the econ department on the econometrics outcome, in short. And certainly if you're in public policy. In the future, we might open it up, but the rules right now very explicitly say social sciences, and it wouldn't happen in the next few years, not while anyone here is at UCLA.
Okay, thank you, Mark. Next question: whether should I double major in stats or enroll in this minor? So I think he kind of answered that with the versus the other stats minor and the slight differences in it. I guess double majoring in stats versus doing this minor kind of is the same thing, except you'll just be going deeper into the statistics. Am I right, Mark?
Yep, that's good.
Yeah. Okay. Michael, I'm sorry. Okay. If I'm a transfer student, I took stats and CC, does that count? Does that count as credit, or do I have to take stats 20? Can you reach out to me on Message Center? I need to check your transfer evaluation, and there it'll tell me a little bit more whether or not that class transfers over or not. So I gotta actually look at the actual class. Make sure it does. Shufan, as a junior comms major interested in marketing, will this minor relate? Can you take that one, Mark?
Yeah, actually, yes. In the sense of it's a very good one to have. As you know, there are actually some excellent data scientists in the communications department on the faculty there, and they have some classes that are statistics, but we had communication students in mind when we designed this. So it's in fact very good. If you're interested in data science in communications, and as you probably know, it's just exploding in communications, then this is an excellent minor to take. You'll find that when you come out with that major in communications and minor in data science, there's going to be a lot of opportunities. In fact, I'll just say as an aside, communications is the field which has most taken on data science ideas over the last five years. It's moved from basically very little data in it to an enormous amount. And it's just worth noting, if you sit back and say, all communication is data. It's either text data or it's audio data, but it's all data. And so the people in communications have sort of taken on to this and have done an enormous amount of analysis of it. I could say a lot about that, but I'll wait to the end. If people are interested, they can come back and I can expand on those comments.
All right, I think we're caught up. Anybody else have any just questions you want to just say out loud?
I'll also just actually, Mike, share again our statistics webpage, which I think is good. Here we go. Is that coming up, the webpage for the department?
Currently, I think we're on like an Apple Pencil page, so maybe it's a different tab.
Yeah, it must be. I don't know. Try again. Well, with this share thing, there's so many things. Let's try this. Or maybe desktop too. This one. Try this one. How's that doing? Yep. Click on the undergrad, social science data. Is that coming through, Amy? Yep. Great. So we click on this, and what we have here, this is all the undergraduate ones we can actually do. And Mike has put together this worksheet. So you can look on this worksheet, and it has, I won't go through it, I can, but just in terms of time, it essentially describes the process by which you can actually apply to the minor. I don't know, Mike, if you wanted to expand on that.
Well, it's pretty simple. As long as you have those preparatory courses done at the top there, and Mark went over it a little bit before. Again, 10 through 15 or any substitute, and Stats 20, Math 33A. So once we see grades posted on your DARs for these classes, and I just verify that you're part of the social sciences division, I'll go ahead and declare you. As long as you have under 150 units. If you have more than 150 units, we just have to take an extra step to check with your counseling unit, which is usually CST. That'll take like a week or something like that, but usually if I approve it, they'll let it go through.
Okay, looks like Kathleen. Oh, there's a couple more questions, Mike, starting
Sure.
from Ming Chu.
I can read it for you guys. You mentioned you can talk more about machine learning. Will there be a class in the minor that is specifically for that?
Short answer is yes, indeed. 101C, which is a required class, is machine learning. I can go through and describe those classes, but yes, it's one of the required classes.
Sorry,
Go on. Do you want to keep going, Mike? There's a couple more.
Yeah, sure. Kathleen, where can I find a list of tracks in the minor? So we don't have like that published yet, right, Mark? So that's
we don't. We can put it on this web page. I actually have it. I can show it if people want to. In fact, why don't I just show it now if there's a little bit of time, and then we'll come back. I'll need to share it, of course.
In the meantime, let me answer this question. Jennifer asked, would Math 170E and 170S be considered substitutes? Yes. for 100A and B. Yes, 170A and E will be considered substitutes for 100A, and 170S is also accepted for 100B.
All right, are you seeing a document flow? Just going to roll down here. These are the tracks. You should be seeing them now. Is that correct? We're working. So here are the actual tracks. This material will be put on the web page. So for the econometrics track, it's you take Econ 143. These are middle and advanced econ classes. I can go through and describe them. It might be easier just to look at the different classes here, but because they're listed only by number, it's not super helpful. These are two political sciences classes. Data and ethics, these are classes from information studies. I'll just really make this comment. Information studies is a sort of an awkward name or is an old name, but as the name suggests, it's really about the study of where information comes from. Now, there's a difference between information and data. Data, if you will, is a raw material from which information is extracted from, but they're clearly highly related to each other. So information studies is vitally important. Having a grasp of information studies is vitally important if you're a data scientist. So this track, Data Ethics and Society track, has classes taken in Information Studies Department, which we think are very important. It's not the sort of thing you do by, running a program or something like that, but the concepts are really vitally important. The social networks track there's a social networks class in sociology, and we've also listed there other classes you can take in statistics that are related to social network data. Geography, these classes are GIS type classes, geographic information systems, which are basically, and geographic information analysis, different forms of doing that component. And so I have a listing of them down here. I'll quickly just go through here. You'll see them marked up. Linear algebra, which is just important to understanding most anything in math. 10, which is the core intro to stats class. 12, these are all basically the same class except general one, or 12, which is an introduction to 13 is introduction to life sciences. They all count, but they're just variations on it. Here's 20, the introduction to statistical programming with R, which I mentioned. Now, the three core classes you take in the actual minor are an introduction to, in essence, regression modeling, a very important one, including generalized linear models and other components like that. The second one is the introduction to design and analysis of experiments. So this is the analysis side of statistics, or not the analysis, the design side, how to design the efficient collection of data. And as I mentioned, the last one is machine learning component to it. Now, here's some other statistics classes here we could go through. I won't just look at them now that you can take. I will mention there is another class in Python, 131, that can be taken there. The 184 I might come back to, but just to get to the social sciences classes, as again, sociology has social networks and often a special research seminar. So it's a special topics in data science, basically. Econ has introduction to econometrics and has a number of very advanced classes as well in the econometrics field. So there's many choices in econ, including financial econometrics. But yeah, I won't say so much more about that. Political science, they have obviously polling, political behavior, political institutions, the statistical analysis of political data, which there's massive amounts of now. Geography, as I mentioned, information systems and spatial modeling. There's some excellent classes, not many, but some excellent classes in communications. Artificial intelligence is a fascinating class. Social networking as well. And then there's the information studies classes I briefly went through. So that's a very, very fast overview of those components, but just to give you a scope of them. And they're available online if you want to look up the course descriptions. Okay, I'll hand back to Mike to see if there's any more questions coming in.
Looks like just a couple. As a transfer student from community college, am I allowed to take 33A at my old school? Yeah, as long as you're not taking, just enrolling in that school and that class during while you're at UCLA. That's the only thing we kind of frown upon. But as long as you're, if that credit's transferable over to us, then sure, we'll take it. Is this minor under STEM? Mark?
I just want to be sure the question is it, de facto a STEM class? Clearly, I mean, it's core down, it's the M in STEM, which is mathematics or statistics. But are you, is there some other designation, Ming Chu, that I'm not recognizing, perhaps some formal listing that I'm not aware of? Or is it just this general question? Could you list it on your resume as STEM classes? The short answer is yes. It's it's mainstream STEM.
Mm-hmm.
But if there's some other question you're asking there, definitely ask it in a different way, and I'll see if I can answer it.
Okay. I think we're caught up.
Can I ask how many students here, with a show of hands, how many students here are in the social sciences? Look at the participation list here. With a show of hands or something like that. Where is the participation list? There you go. Great. Oh, good. All right. So yeah, if you're in the social sciences, great class. If you're in a social science which doesn't have a lot of data science in it, and this is not critical of the departments. As I've said, this is something that's happened very recently, and departments are moving towards it. It just takes time to change. We're stepping in. We're saying, because we're already teaching these classes, we can offer them to social science students. So if you're in an area that doesn't have a lot of social science offerings, we're here. So, and we're working with the departments you're in to offer these classes. So we're very, very welcoming of students. There's a couple more questions. Let's see, or one from Christine. Mike, do you want to take that?
Prereqs for Math 33A. I'm assuming you're talking about math classes. You'll have to ask math department for that one because we don't control their classes. It looks like prereqs for Math 33A only offer fall. Yeah, so that's all going to be math. You'll have to ask the math department for that. I'm not sure, what their stuff is. Possible to take calculus in your still do that. That'd be tough if you're taking calculus in your senior year. To all the stats classes. I mean, we'd have to see if we could do a plan, but I mean, it doesn't seem likely in 1 year. But if you reach out to me on Message Center and let's take a look. We never know. You never know, depending on what you've already done. Okay.
I'll just mention one other thing just briefly. I'm going to share my screen again. One of the 4 classes that's required is this societal impacts of data class. So you can see that here. This is called Stats 184. And this is about things like data privacy, data protection, things often called algorithmic bias in the literature, and ideas of anti-discrimination and equality. Now, I've put these words in green. They're not the sort of things you see in a typical statistics class, but they all fall under the societal impacts of data. For example, many of you might have heard about the congressional testimony on Facebook, which is going on now. And say, well, that can't have anything to do with statistics, but in fact, it's very related to it because the impact of Facebook on society is very large. And it's because of the data it collects on people and how it uses that data. So that will be the sort of things that will be discussed in this class. There's not going to be an awful lot of mathematics or statistics, at least computation in it, but it's going to really explore these issues because we think they're core issues to anyone these days being a data scientist. The data doesn't exist outside society. The data is embedded in society. So I'll stop there. That's probably the end of my presentation. We'll just see one more time if there's any more questions. Great. Hopefully this has been instructive. I want to thank Mike in particular for answering all the difficult questions, and good luck. And we hope to see you in the coming years.
Thanks, guys. Thanks for having us.
Thank you, everyone. Yes, the recording should be sent out after, or it'll be posted on our YouTube or our Facebook. So yeah, thank you.
Bye. I'm going to stay on just in case there's 1 or 2 private questions. Maybe not. Even Mike's gone. All right, Amber or Amy. Sorry, I don't know what I'm thinking of. I've been working too hard.
Yeah.
Anyway,
I saw you had
great.
a seminar today too, so you're pretty busy today.
Yeah, I had a seminar and did a whole bunch of other things. But no, it's good. I thought actually it went reasonably well.